This class is one of several on the topic of lean management, and as such it's important that you check the other classes, make your own notes, view the classes several times, and do some reading on the area and make sure you've got a good set of notes. But in this class we're going to talk about issues in setting up flow systems, and we're going to talk about bottlenecks and constraints and related topics. So let's start. We're going to talk about continuous flow manufacturing, CFM. Now, according to this, work should flow through the process without interruption, one unit at a time, based on the customer's demand rate. So the customer places an order, and that activates the system, and then the order should be completed one unit at a time, flowing through the system, and the system should flow smoothly and efficiently from start to finish. Ideally, the raw materials and components should be just delivered in time, so the supplier of the raw materials and the components that are needed should just make a delivery at the start of the process, and the raw materials and components should then flow through the various machining operations or the various process operations until it gets to the dispatch stage. Delays associated with setting up equipment, moving work between departments, storing work because a needed resource is unavailable, equipment breakdowns, and so on. All of this must be eliminated. All of these must be stopped. All of them represent a waste. All of them represent a waste of resources, a waste of time, and detract from the overall efficiency of the organization. Now, converting to mixed model assembly and sequencing. Well, mixed model assembly, items are produced smoothly throughout the day rather than in large batches of one item, followed by long shutdowns and setups and then another large batch of another item. So this model, items are produced smoothly throughout the day. There is a continuous flow of work coming through, and this work is standardized. So each one comes through, and when it gets to the end, it's a smaller flow, and it's much better, much preferable to do that than to have large batch runs where large amounts of raw materials are required, a lot of processing time, and the final output is then put into a stores and sits idle waiting to be delivered. Whilst it's in the stores, it is idle. Whilst it's in the production process, it's also not earning anything for the company. So the whole idea with lean management is to minimize the amount of time and amount of resources that are required to get the output to fill the orders. So large batch processing is wasteful. So the idea of the lean approach is to have continuous, smooth production. Well-maintained machines, well-trained workers, items like raw materials and components just arriving just in time to start off the process, and at the final stage, when the items go to dispatch, they go to complete an order that's already been received. That's efficient, as opposed to large batch production stored away in the hope or the expectation that at some future date somebody will place an order for it. That's wasteful. Now, there are constraints within systems. As we'd expect, companies don't always have the right amount of facility in all respects. So there will be areas where the company is
low on capacity, and there are other areas where it's got plenty of capacity. So there are constraints in production systems, and generally speaking, most companies have got this problem that they've got to work around. So the theory of constraints, well, this is a systematic way to view and analyze process flows. When a process is flowing, when items are moving through the system and value has been added to them, there are constraints, and it is necessary to have a systematic view of the whole system to see where the constraints are. A key aspect of the theory of constraints, TOC, include identifying the bottlenecks in the processes and balancing the workflows in the system. Bottlenecks means there is congestion. There is too much demand for a particular resource, and the resource is working at full capacity and it's still not clearing the backlog. That's a bottleneck. There is a problem. And then the whole system can only run as fast, perhaps, as that particular part of the system is running. Where the bottleneck occurs, that determines the speed of the system. So it's vital that the management concentrate on bottlenecks, concentrate on areas where there is hold-up, where there is congestion. The management should focus their efforts there to try and relieve that situation, get extra capacity, or find some way of working around the problem. The following 10 guidelines capture the essence of the theory, and some of these may seem a little vague and sometimes a little popularist in their appeal, but let's look at them nonetheless. For a start, we're dealing here with flows, and the emphasis should be on the flow throughout the system, not on the capacity of the system or the capacity of the individual components in the system. What we need to look at is the flow. Is there a bottleneck? Is there a hold-up? And it could be that the capacity in some areas is too much, that the items flow through smoothly, but there's actually slack in that system, in that part of the system. Slack means a wasted resource. However, unfortunately, the world doesn't come in continuous amounts. The world comes sometimes in discrete capacity. So a machine might have to produce 1,000. It can't produce 900. It could be the case that the machines have to be configured in a certain way. The system only requires 700, but the machine's going to produce 1,000 anyway. Now, it could be the case that there is a constraint on what machines can do. So the machine is overproducing. It's got too much capacity, but there's no choice. That was the machine. That's the design of the machine. That's what the company has to live with. So the management must find some way of utilizing the machine and optimizing, given the fact that the machine has got excess capacity. But as far as possible, management should look at the flow through the system and not be concerned with the capacities too much unless there's a major item of slack in the system or bottlenecks in the system. When a bottleneck arises, that determines the whole speed of the system. All the system can only go as fast as the slowest machine. So it's necessary for management to focus in on where there are bottlenecks, where there are hold-ups. Fluctuations in a tightly connected, sequence-dependent system add to each other rather than averaging out. Fluctuations don't necessarily average out. Fluctuations in the system may add to the complexity of the system and add to the problem. So that fluctuations in demand, fluctuations in the demands on the system, if it's a production system, don't necessarily average out. They simply add to the problems. The next order, coupled with the previous order, adds to the bottleneck. exacerbates the problem. It does not reduce the problem. And the utilization of a non-bottleneck is determined by other constraints in the system, such as bottlenecks. So whenever there is a congestion at one machine, it may lead to the utilization of other machines, trying to find a way around the bottleneck, bringing other machines into play, into use. So utilization of a non-bottleneck is determined by the other constraints in the system. Utilizing a workstation, producing when material is not yet needed, is not the same as activation. So using resources is not necessarily a good thing if the resources are not required. If the output of that resource is not required, then using it is not a good idea. If the output of a machine is not required, then don't use the machine. It's almost common sense. But simply because the machine exists doesn't mean it has to be used. It could be that it's best to leave the machine turned off and deal with the machines that are required. So simply because a workshop has got many machines doesn't mean all the machines will be working. Now that is wasteful, and ideally that machine should not exist, should not be a part of the company, and there should be some way of disposing of the machine and turning its value, turning its market value into cash, which will help the business. But simply because resources are there doesn't mean that they're good, that they are useful. An hour lost at a bottleneck is an hour lost for the whole shop. When there is a bottleneck, when there is congestion at a machine and the machine is working flat out, but it's not producing enough, it doesn't have the capacity to deal with the backlog. If that's the case, then the whole stream, the whole output of the business is determined by that one machine. That one machine is determining the speed of production in the system. So it's imperative that the management focus on bottlenecks and hold-ups in the system to ensure that the system runs smoothly and according to the demand levels being placed on it by customers. So a machine which is not running smoothly or has bottlenecks or it's got hold-ups, that one machine is determining the speed of the whole system. All the other machines must scale to meet the capacity of that one machine which is causing the problem. And an hour saved on a non-bottleneck is a mirage. It's an illusion. If machines are running smoothly and producing the output that's required, and they've got capacity, if extra time can be saved on that machine, it doesn't mean anything. The whole problem is on the machine that's causing the hold-ups, not the machines that are running smoothly and so on. So it's pointless spending effort on the machine that's working well and meeting its requirements. It's the machines that are causing the bottlenecks are the ones that need attention. So the bottlenecks govern the shop throughput and work in progress inventories. If a machine is causing a bottleneck, causing a hold-up, and it's near the end of the process, then the hold-up, the items which are waiting to be processed, they are work in progress, and they are sitting idly by waiting to be processed. So the company is dealing with work in progress
almost by default. It's not planned work in progress. It simply means one of the machines is causing a hold-up. All the work from the other machines is coming through at the appropriate pace or the appropriate level, and they get to the machine with the hold-up, and they're just sitting waiting to be processed. In that sense, they are work in progress, and it's wasteful. The transfer batch need not be the same size as the process batch. To get continuous production, if the information from the buyers is reliable and if it doesn't vary a lot, then continuous production is possible, which is the most efficient. That scale of production is determined by the size of the orders coming through from the customers. So there is no need to produce items in large quantities, put them into stores, waiting for the orders to come through and meet them out of the stores. It's possible to meet the orders out of current production. But it's necessary to scale the whole activity of the business to the customer order size. The size of the process batch should be variable, not fixed. It should be possible to vary the scale of the operation. Given the existing set of machines or equipment or capacity of the unit, there should be some way of altering the levels of output, stepping it up slightly or stepping it down, according to what the customers want. And again, trying to avoid large volume production which is just stored away and sitting idle waiting for the next customer order. So instead of using stores and producing for the stores, they're producing for specific orders that have come in. But the production system itself can scale up slightly or scale down according to the orders. And the customers can be told when the order will be completed. The quality is guaranteed. The production system is running smoothly. The machines are well maintained. The workers are motivated and well trained. So the system is optimized. A shop schedule should be set by examining all the shop constraints simultaneously. Now, the crucial point is the one I mentioned earlier, and that is the machines or the areas of the production system that are causing the bottlenecks. But in fact, all of the system should be reviewed. All of the system should be checked to make sure that each part of it is synchronized. Each part of it links to the one in front and the one further back. Each process is connected up. So even though there are perhaps many machines in the production process, we could look at the whole process as one big machine, just different parts of the machine processing through the raw material into a semi-processed form, into a more advanced processed form, and into a final product at the end. So the whole system should be looked at and optimized to ensure that the layout is correct, the machines are properly tooled up, properly maintained. All of the issues to ensure smooth production are in place. And particular attention is being paid, as I said earlier, to areas of concern, areas like machines that are breaking down or not working at the appropriate speed or for whatever reason are causing bottlenecks. Now let's look at implementing the theory of constraints. Well, first of all, identify the system's constraints. So it's important to be aware of the shortcomings of the system. be aware of where constraints exist, and management should concentrate and focus on those areas and try to find solutions or ways to alleviate the problems caused by the constraints. Exploit the constraint if possible. If the constraint is a major issue in the production process, then exploit it in the sense of focusing in on it, concentrating on it, and putting whatever slack resources there are in the system into ameliorating the constraint, reducing the constraint. So exploit the constraint in the sense of look at its requirements and bring management resources to bear on the constraint to try and alleviate it. So it's been exploited. It's been used in a sense for management purposes. It's been used to also to learn about the system, and it can feed into future investment decisions. It can feed into knowledge of how the system works. It can feed into the solutions to constraints, can feed into the whole learning process and the knowledge base of the business. So everything else becomes subordinate to the constraint. The constraint is what management does. The rest of it is working smoothly, let's say. Management is there to deal with the constraint. But once the constraint is dealt with and the constraint has been either removed or the constraint is less severe, once that happens, then management may move off to look at other areas. But whilst the constraint is binding, then management needs to focus on it. And as I said earlier, the constraint will determine the speed of the overall system. If the system is integrated, running from part 1 to part n, where there are n parts in the system, if that's the case, and one of the parts operates as a constraint, operates as a brake, it's a brake on the whole system. So the speed of production is determined by the constraint. So alleviate the constraint. That's the purpose of management, simply to alleviate the constraint. So if the constraint has been alleviated, has been dealt with, then move to the next constraint. Move to the next one, which is either operating as a constraint, perhaps not as severe as the first one, the one that's just been fixed, but move to the next one. It may be that there's one likely to arise, or there's a weakness somewhere else in the system. Management should shift its focus then from the one that's been solved to the one that's likely to happen next. And in this way, the system is capable of smooth functioning at a constant rate. I did say earlier that the system can scale up slightly or scale down depending on the capacities of the machines. Obviously, if it scales up, bottlenecks are more likely to arise. If it scales down, if it moves down its production levels, constraints may be automatically resolved. That's all we need to deal with on this session. So we've looked at constraints, we've looked at optimizing the system, we've looked at management focus in the context of constraints. That's all we need to do in this session. Add this to what you've learned from the other videos and from your own reading, and make a good comprehensive set of notes for yourself. But that's all we're going to do here, so I'm going to leave it at that and say thank you for watching.